Hey everybody, this is Larry. This is me doing whoops, one button. Yeah, okay, fine. What am I doing? I am doing day 18th of the May Leetcode Day Challenge. Hit the like button, hit the subscribe button, join me on Discord. Let me know what you think about this poem. And as you can see, well, maybe not, I don't know. But yeah, my intro is me in Georgia, in Tbilisi. So yeah, hope you enjoyed that drawing video. Let me know what you think. Either way, skip ahead if you need. But okay, let's take a look at today's problem. It's going to be 1557 minimum number of vertices to reach all nodes. So given a directed asynchronic graph with n vertices numbered from 0 to n minus 1 and an array edges where edges of I is from to 2, represent a directed edge from node from I and node 2 sub I. Okay. Find the smallest set of vertices from which all nodes in the graph are reachable. It's guaranteed that a unique solution exists. Notice that you can return the vertices in any order. So I think this is basically some formulation of topological sort. My first inclination is that if you get all the nodes of 0 in degree, it should be good enough. The reason is, and to be clear and to be honest, I'm not 100% confident at this point. Like if I was doing a contest or something like this, that would be my first instinct. But I would have to I would have to think about it a little bit to prove it to myself, right? And also just to kind of on that point, the proving to myself isn't, it's one of those things that you get by practicing. And what I mean by that is that when you practice enough, then you're able to, maybe you could say cheat, you could say intuition or whatever, but at the end of the day, it's because you've done the work enough that you know certain things are true, right? Because I haven't done it enough, because I haven't practiced enough, I don't know that I could confidently say that for this one. So in that case, I'm going to just start with some, the one thing I would say is that what I said is definitely, well, yeah. So you can prove it very quickly because there are really only two cases, right? For each node, there's 0 in degree and nodes with more than 0 in degree, right? Nodes that are with non-zero in degree, it how do you say this? Well, if that means that an edge is pointing to it, right? Which means that by definition, instead of picking this node, you just pick the node that is the parent of it, if you will, right? And then you could kind of maybe recursive isn't the right word, but you could kind of iteratively and kind of go through that process to kind of get the parent node, right? And then the 0 degree node in that case would be optimal because literally you cannot reach this node from any other position because literally has 0 nodes, right? So it has to be in the starting set. So what I told you is kind of probably close to the proof. I mean, maybe it's not as mathematically, it's not like precise, but it's vaguely rigorous enough to be the proof. It's just that, yeah, and this is off my head, just to be clear, right? And these are things that, and I don't mean that as in like whatever. What I mean by that is more that that is what I would need to convince myself to start coding or like in an interview and talk about it and stuff like this, right? So in that thing let's get to it, right? So it's equals 0 times n from 0 to n minus 1, right? Yeah, okay. So then for u, we in I got myself confused. The u doesn't even matter, I don't think, to be honest. I mean, I usually use uv for, I don't know, that's just like common notations, right? And then now we have an answer is equal to, and then for I in range of n, if in degrees of I is equal to 0, then answer parent I. Hopefully this is right, otherwise and I'm gonna embarrass myself. Well, I mean, okay. Oh, whoops. Why did I do it? Let's give it a submit. And yeah, that seems pretty okay. I mean, this is gonna be. Is this a tree or anything? No. It's tempting to say this is linear, but it's not quite linear. It is v plus e to be more precise. The reason why v plus e in this case is not technically linear is because n or v is not the size of the input. So yeah, so that's basically it. Because for example, in this particular, and I'm giving you an extreme thing, but it's still going to be all of v plus e time all of v space, right? And the reason why this isn't linear is because of a very simple thing, right? Where if n is a billion, and then there's no edges. It doesn't matter, right? If n is a billion, well, the input size of n is not a billion. N is a billion is the input, but not the input size. The input size is actually the number of bits needing to represent a billion, which is say 31 bits or 30 bits or whatever it is. I think it's 30 bits. Yeah, 30 bits, right? So, and that means that for every increment of the input size, meaning you go from 30 bit to 31 bit, actually the space doubles, right? So in that sense, it is exponential, and therefore, technically, this is exponential, but we just say v plus e is probably fine for most people to understood. But just to mostly because I think from so yeah, and there are some optimizations that you can do, but because if at least for the if n is a billion case, you could probably clean this up. You could use this to just use keys. So if you do it that way, then I guess technically it would be linear. It's just that I guess I was lazy. For example, you could rewrite this to use a dictionary or something like this, collection.counter, right? And then this is what's it called? Length of well, it would be just I forget how it goes, like dot keys or something, right? So now here, with just some minor changes, this is actually linear time, right? Because now this reduces to O of E time and O of E space, right? The reason is because now counter is we only need space that's bounded by edges, right? Meaning if there's a million edge, in degree will have at most a million entries. So yeah, and same thing with keys, right? It only has the number of edges in the number of things. So then now this reduces it to O of E time and O of E space. And in this case, E is the least dominant one. Usually it's not, but in any case, so yeah, so now we did reduce it to linear time, linear space. Yeah, just kind of thought I'd bring it up because and this time in a little bit more detail, because otherwise I think I forget what I mean. Anyway, that's all I have for this one. Let me know what you think. Stay good, stay healthy, take good mental health. I'll see y'all later and take care. Bye bye.